Hi students, welcome to today's class. In the yesterday's class, I have explained what is homogeneous function and what is homogeneous differential equation. Okay, now in today's class, I am going to explain how to solve a given homogeneous differential equation. Here we have two types of homogeneous differential equations. Let us see them. If the homogeneous differential equation of the form dy by dx is equal to some f of x comma y by g of x comma y. Okay, now. So you may ask one doubt, sir, in the previous class you said that dy by dx is equal to capital F of xy, where the degree of the capital F of xy is also a homogeneous function, degree is 0. Yes, I am also saying that, and these both definitions are same. So here numerator function and denominator functions both should be homogeneous function of degree same. F of x comma y and g of x comma y both should be homogeneous functions of degree same. The degree should be same. If it is a numerator, degree is 5, the denominator degree is also 5. I already told how to find out the degree of the homogeneous function. Just to keep in place of x lambda x, in place of y lambda y, take common. So whatever may be the lambda power is there, that power is the degree of that homogeneous function. So the numerator and denominator both should be homogeneous differential homogeneous functions of degree same. Understand? Then only we call it as a homogeneous differential equation. If it is of this form dy by dx, this is one type of homogeneous differential equation. Another type is dx by dy, that is equal to f of x by g of x by x comma y. So this is a dy by dx, here dx by dy. Here also the same condition applies. What is the condition? Both should be homogeneous functions of same degree. Understand? On the whole, the degree of that homogeneous function is 0. Why? Because same degree means it gets cancelled, lambda power 0 you will get. Okay, right. Then how to solve this problem? How to solve this differential equation is, so here put y is equal to Vx. Put y is equal to Vx, so that dy by dx is equal to v into x derivative is 1 plus x into dv by dx. So wherever dy by dx is there, substitute v plus x into dv by dx, and wherever y is there, substitute y is equal to vx. Okay, now, so two substitutions we have to make. The first substitution is v plus x into dy by dx, wherever dy by dx is there. Wherever y is there, substitute v by x, otherwise v is equal to y by x. V is equal to y by x, you have to substitute at the end. Wherever after getting the answer, so you have to resubstitute v is equal to y by x. After substitution there, you will get this form into variable and separable form. Then we will solve the problem easily. But there what have to substitute? X is equal to vy. X is equal to vy. Here y is equal to vx, there x is equal to vy. Okay, then what will be the your, so dx with differentiating with respect to y, dx by dy is equal to v plus y into dv by dx. Understand? Y derivative is 1. With respect to y, you have to write down. So wherever dx by dy is there, substitute this. Wherever x is there, substitute v into y, and the problem will reduce into variable and separable form. So this is called solving the homogeneous differential equations. There are only two types. One is dy by dx, another one is dx by dy. Then how to remember? Dy by dx, starting top, what is there? Y. Therefore y is equal to vx. Here dx by dy, in the top what is there? X, that's why x is equal to vy. Here top y, y is equal to Vx. Here top x, x is equal to Vy. That is the trick to remember the how to general. Why? Because I am telling generally student get confused. What her substitute y is equal to Vx or x is equal to Vy. No, what is the top here? Y. Therefore, y is equal to Vx. Therefore, we will get dy by dx. Understand this? Now, I am going to explain one problem using this, how to solve this differential equations. Okay, let us see the problem. Welcome to this problem. So, here one problem is given. Show that the given differential equation. So, this is a differential equation x square plus xy into dy is equal to x square plus y square into dx is a homogeneous differential equation and solve it. Okay, first we will concentrate on that to show that that is a homogeneous differential equation. So, what is given this? So, this is a x square plus xy into dy by dx is equal to x square plus y square into dx. So, this is equal to, you can write it as a dy by dx or dx by dy. So, better always try to write dy by dx only. So, if it is not possible, then we can write down dx by dy. Now, this is equal to dy by dx is equal to x square plus y square upon x square plus xy. Now, so this is a differential equation. Now, we have to check whether it is a homogeneous or not. Now, first consider this function. So, we have to show that that is a homogeneous function of degree 0. Right. For that, so how to check it is, wherever x is there, substitute lambda x. So, this is a lambda square x square. This is also lambda square y square by lambda square x square plus lambda square xy. So, wherever x is there, lambda x, lambda y, lambda square xy. Take lambda square common outside. If you take lambda quotients, x square plus y square. In the denominator also, x square plus xy. Lambda square gets cancelled. Therefore, what you will get? Lambda power 0 into x square plus y square by x square plus xy. So, we got it or not? So, this is a homogeneous function of degree 0. On the whole, this is a homogeneous differential equation. That's all. Don't say degree 0. This is a homogeneous differential equation. That's all. Okay. So, the homogeneous differential equation, the function, whatever may be the function here, the degree should be 0. Yes, it is proved. Now, concentrate on solving it. How to solve this differential equation, then how to solve it. So this is of the form first type, dy by dx. Then how to do? Just now I told you how to remember that. So here what is there? Y is there. That's why put y is equal to Vx. Whatever may be in the numerator, y. Put y is equal to Vx. Okay. No need of getting any confusion or nothing. So, y is equal to Vx or x is equal to Vy, nothing. So, what is the numerator? Y. Put y is equal to Vx. Okay, now what is the derivative of this? So, this is equal to dy by dx is equal to V plus x into dv by dx. So, wherever dy by dx is there, simply substitute this. V plus x into dv by dx is equal to. So, this is equal to x square plus y square means v square x square, v square x square by x square as it is plus x into y means how much? Vx. Y is Vx. Right. Any more cancellations? Surely, definitely x square will be, x term will be cancelled. So, in the numerator take x square common outside, x into x square, take x square common outside. Definitely, they should be cancelled. 1 plus v square by 1 plus v. Understand? So, take v to right hand side. So, what happens? X into dv by dx is equal to 1 plus v square upon 1 plus v minus v. Okay, na? So, what is the simplification we will get? 1 plus v square minus v square by 1 plus v. Okay, plus v square minus v square, you will get cancelled. In the numerator, you will get here 1 minus v by 1 plus v. In the numerator, 1 minus v by 1 plus v. So, this all together x is equal to dv by dx. Now take variable and separable method. All v terms one side, all x terms to one side. So this will become 1 plus v upon 1 minus v dv is equal to 1 by x dx. So this is of the form. Surely after substitution y is equal to vx, definitely it will be of the form variable and separable. So then how to solve this variable separable method means take integrating on both sides. Let us continue our solution. Welcome back. So this is of the form variable and separable form. So let us integrate on both sides, right? It is integrating on both sides. So if you saw right hand side is a very clear. So this is ln of x, very clear. So what about in the left hand side derivative? What is the integrand? This is 1 plus v by 1 minus v. So you can do a very intelligent guessing. So you can do you can write down like this. In the numerator, can I write down this as 1 plus v, no? So this is, can I write down 2 plus v minus 1. So therefore 2 minus 1, 1 by 1 minus v. 1 minus v. Okay, can I write down dv? So that is integral of 2 minus of 1 minus v by 1 minus v dv. Okay, I have taken minus common outside. Now separate this integral of 2 by 1 minus v minus 1 dv. Okay, is it okay now? Now check it here. Minus 1, 2 minus 1, 1, minus into minus plus, 1 plus v by 2 minus s, that's all. So this is a ditto step you will get in all the 4 steps. Now let us integrate this. So 2 by 1 minus v. 1 minus v integral is minus 1. So you can write it as minus 2. You can take minus 2 common outside. So this is a ln of 1 minus v minus 1 integral with respect to v. See here, with respect to v, 1 integral v is equal to ln of x plus ln of c, constant of integration. Okay, now. So let us simplify this. So this is a minus, you can take common type. So 2 times ln of 1 minus v plus v is equal to ln of cx. Okay, so this is equal to minus ln of 1 minus v whole square into v is equal to ln of cx. Okay, now, right. So this minus, if you take that side, plus will be there. So that is ln of cx plus ln of 1 minus v square into v is equal to 0. Okay, now. So this is altogether, I can write down ln of cx into 1 minus v square into v is equal to 0. So this is a logarithmic form. If you convert into exponential form, so this is a cx into 1 minus v square into v is equal to e power 0, 1. So wherever v is there, so already we have substituted y is equal to vx, therefore v is equal to y by x. Wherever v is there, substitute y by x, that is equal to cx into 1 minus y square by x square into y by x is equal to 1. Take LCM, x square minus y square, x cube, take that side. So this will be your final solution. This is the equation of the curve whose solution is this. Okay, now. So the very easy problem. This is generally students feel difficult while writing this to this form, this to this form. Okay, now. So otherwise, so sir, how can we get sir 2 minus 1? The simple method is otherwise divide 1 plus v with 1 minus v. Otherwise minus v plus 1. Then you can get easily what you call that mixed form. You can get mixed form also. It is easy to solve it. Okay, now. I hope that you enjoyed this solution. Let us see one more problem. Welcome to this problem. So this is one of the very interesting problem. So solve 1 plus e to the power of x by y times dx plus e to the power of x by y times 1 minus x by y dy is equal to 0. So simply he will give solve. Of course, in the options there will be available. Now how to do this problem? So let us see that. First thing is take dy term to right hand side. So that is 1 plus e power x by y. Dx is equal to minus e power x by y, 1 minus x by y dy. Okay now, right. So take dy term this side and remaining term that side. So therefore dx by dy is equal to minus e power x by y, 1 minus x by y divided by 1 plus e power x by y. As already this example I have given, so this is a homogeneous differential equation. This is a homogeneous differential equation. Then how to solve this differential equation? So what you have to substitute? I already told you. So here what is in the numerator? X is there. In the top x is there. That's why x is equal to Vy. X is equal to Vy. So this is the second model I am telling. So therefore in place of dx by dy, so now differentiating with respect to y on both sides. Therefore dx by dy is equal to V, y derivative with respect to y 1 only plus y into dv by dx. Okay. Now you substitute all these things in the given equation. What happens? See here, dx by dy is equal to V plus y into dv by dx is equal to minus e power x by y. So from this x by y value is equal to how much? V. X by y value is V. E power V minus 1 minus V by 1 plus e power V. Okay, right. Take V to right hand side. What happens? So this is a y into dv by dx is equal to. So this is a e power y. So take minus inside, that is a v minus 1. 1 minus v become v minus 1 upon 1 plus e power v minus v. Okay na? So take cross multiplication, you will get e power v into v minus e power v minus v minus v minus e power v into v by 1 plus e power v. Okay, right. In the numerator anything is cancelled, e power v into v minus e power v into v, we can get cancelled. Right, what remains here? So this is equal to minus of e power v plus v by 1 plus e power v. So this is all equal to y times dy by dx. So take all y's x, so this is a so y into dv by dx. So here we should not get y here. So x is equal to v into xy, v into y derivative is 1 plus y into dv by dy you have to get, dv by dy, dv by dy. Okay now, right. The thing is now take all y terms one side, v terms to one side. Let us see what happens. So this is equal to 1 plus e power v by e power v plus v dv is equal to minus 1 by y dy, minus 1 by y dy. Okay now. Now, so this is in the variable and separable form. So let us integrate on both sides. Integrating on both sides. If you luckily, if you see numerator by denominator. So what is the derivative of denominator? E power y, e power v derivative is e power v, v derivative is 1. So therefore, the derivative of the denominator lies in the numerator. Therefore, this is equal to ln of e power v plus v is equal to minus 1 by y integral. So this is equal to ln of y plus ln of c. Already I told that whenever the sides of ln's are there, so you can put ln of c as a constant of integration. So this is equal to ln of e power v plus v. This is equal to ln of c by y. Log a minus log b, log a by b. So you can remove ln. So on the both sides, e power v plus v is equal to c by y. What is y? What is v? V is nothing but x by y. So your final answer is e power x by y plus x by y is equal to c by y. So you can multiply with y on both sides. So your final answer is y into e power x by y plus x is equal to c. So this will be your final answer. So dear students, so from this what you have to remember is you can write it as a dx by dy, it is better. If you write down dy by dx, the problem will be somewhat difficult. Why? Because here x by y, Here also x by y is there, x by y is there, x by y is there. That's why x by y is equal to v, therefore x is equal to vy. It's a very intelligent substitution. Okay. So now I am going to explain. So these two models are homogeneous differential equation. Then how to solve non-homogeneous differential equation. What is meant by non-homogeneous differential equation? Means an equation which is not non-homogeneous is called it is not homogeneous is called non-homogeneous differential equation. Then how to solve such a type of non-homogeneous differential equation? Let us see that. Welcome back to this concept here. Non-homogeneous differential equations. Non-homogeneous differential equations means what I told. A differential equation which is not homogeneous is called a non-homogeneous differential equation. So if any equation of the form dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2, where a1, b1, c1, a2, b2, c2, all 6 are constants. Okay, now, so let me give one example of this equation. So this is, for example, dy by dx is equal to 2x plus 3y plus 7y. So 3x plus 4y plus 8 is equal to 0. So that is called a non-homogeneous differential equation. Okay. Then how to solve this non-homogeneous differential equations is, there are 3 types of non-homogeneous differential equations are there. The first one is, observe the coefficients, that is a1, b1, a2, b2, not c1, c2. So forget about c1, c2. Observe the coefficients of x and y in the numerator and denominator. If it is happens to be a1 by a2 is equal to b1 by b2, the ratio a1 by a2 is equal to b1 upon b2, the ratio is equal, then we can put a1x plus b1y is equal to some constant. Sir, tell me one example, sir. Yes, I will take one example. For example, dy by dx is equal to 2x plus y plus 3 by 4x plus 2y minus 7. Okay, now observe this differential equation, non-homogeneous differential equation. Observe here, x coefficient is 2, x coefficient is 4. 2 by 4, how much? 1 by 2. Here y coefficient 1, here y coefficient 2, 1 by 2, 2. So this comes under first type. Then what have to do? Numerator. What is the numerator here? 2x plus y is equal to some t or z, something other than x and y you take. Now your problem, now differentiate this. So this is a 2 plus dy by dx is equal to dt by dx. Therefore your dy by dx is equal to how much? Dt by dx minus 2, that is equal to 2x plus y value is how much? T plus 3 by. So here you can take 2 common outside now. You can take 2 common outside. 2 times 2x plus y, that is equal to 2t minus 7. Now take minus 2 to that side. Again it will form into variable and separable method. Okay, now the first thing is, you have to concentrate on the variables a1, b1, a2, b2, not constants. Okay. So this is the first method. Sir, if it is not equal, a1 by a2 is not equal to b1 by b2. a1 by a2 is not equal to b1 by b2. Then this is somewhat a typical method. For example, in the here I wrote one example. 2 by 3, here x coefficient is 2, here x coefficient is 3. 2 by 3 is not equal to 3 by 4. Such type of problems, then how to solve is somewhat it is a somewhat lengthy, it makes a lengthy. So by proper substitution, so wherever x is there, small x is there, put capital X plus h, and small y is there, put capital Y plus k. Then after differentiation you will get capital Y by capital X is equal to a1 capital X plus b1 capital Y by a2 capital X plus b2 capital Y, you will get c1, c2 will go. Okay. Then after finding, how to find out here c1, c2 value becomes this, you will get here. You have to solve these two equations. you have to solve these two equations, h and k you will get. After substituting h and k, you will get the solution. So, this is a somewhat a typical method, but one thing you remember that, so whenever a1 by a2 is not equal to b1 by b2, your substitution is small x is equal to capital X plus h, small y is equal to capital Y plus k. This is the second one. Coming to the third one, that is a2 plus b1. Where is a2, where is b1? See here. So, this is a a2, this is b1. If it is a2 plus b1 is happens to be 0, sum of the x coefficient and in the numerator and y coefficient in the denominator and numerator. So, here a2 is the coefficient of x in the denominator, y is the coefficient, b1 is the coefficient of y in the numerator. If it is a2 plus b1 is equal to 0, then we can find this derivative by taking proper grouping the terms. Okay, proper grouping that means if you group the terms, then there will occur say substitution you will get. Okay, after substitution we will get the answer. So, basically these are the three models of the non-homogeneous differential equations. Okay, now, right. I hope that you understand this concept. So, let us take some problems so that you can completely understand this concept. Okay, now. So, let us start the problems. Dear students, welcome to this problem. So, the problem is dy by dx is equal to x minus 2y plus 5 upon 2x plus y minus 1. So, by seeing immediately, you have to, the first thing what should come in your mind is, this is a non-homogeneous differential equation. This is a non-homogeneous differential equation. Why? Because here plus 5 minus 1 constants are there. So, even though if you substitute here lambda x, lambda y, you cannot take lambda common outside. Okay. So, clearly it is a non-homogeneous differential equation. After getting that idea, then there are three types are there in non-homogeneous equations. The first type is what? a1 by a2 is equal to b1 by b2. Second one, a1 by a2 is not equal to b1 by b2. The third one is a2 plus b1 is equal to 0. Check it here. First, definitely it won't satisfy. 1 by 2 is not equal to minus 2 by 1, right. Second also satisfies, Before that, check this is third one is satisfies or not. Yes, it satisfies. Why? Because here a2 value is 2 and b1 value is minus 2. 2 minus 2 is equal to how much? 0. General student, they will start doing. So, therefore, 1 by 2 is not equal to minus 2. Therefore, they start in the second method. So, it takes a long time. But don't have a look. Here 2 is there, here minus 2 is there. So, their sum is 0. Okay, now? Then how to do that? What I told for this third type? Proper grouping I told. Now I am going to see that proper grouping. Right. So, take this cross multiplication, what you will get, and this also you can do cross multiplication. So, this is equal to 2 into x dy plus dy into dy, y into dy minus dy is equal to x into dx minus 2y into dx plus 5 into dx. Understand this? Just I multiplied dy with these three terms and dx with these three terms. Now, proper grouping means, see here I am grouping like this. X dy, 2x dy minus 2y dy. Take to one side, otherwise you bring all the to one side, nothing wrong in it. So, this is a 2x dy. Write down here 2y dx plus this is y dy minus dy minus x dx minus 5 dx is equal to 0. Okay, now. Right, in this here you observe here, take 2 common outside, x dy plus y dx plus y into dy into dy into dx into x, 5 into dx is equal to 0. So here in the yesterday's class only I told, this is can be written as 2 times derivative of xy. This is nothing but derivative of xy. So this is same y into dy minus dy x dx minus 5 into dx is equal to 0. Now what you have to do is integrate. Ready? So integration and differentiation will be get cancelled. So 2xy plus this is y square by 2, this is y minus this is a x square by 2, this is 5x plus c is equal to 0, otherwise u is equal to c. You can write down u is equal to c. This is your final answer. Remember students, here 2, here minus 2 is there, then you after proper grouping you can solve this problem. I hope that you understand this solution. Welcome to this problem. So it's a very nice problem. So even though how to solve this problem, see here some problems are there. Generally students, they will start doing dy by dx is equal to y into e power xy by, and they start doing like this. So by substitution, whether it is a non-homogeneous or homogeneous, checking all these things. But without doing that, within a short trick, yesterday I have explained what are the short trick formulae. Using that short trick formulae, you can do this problem very easily. So you have, what the thing is, you should have a logical thinking. Then how to do this problem? Let us see the solution. See here, first I will write down this term as it is, dx. So the term separate dy for both the terms, x into e power x by y plus, sorry, into dy plus y square into dy, x into e power x by y into dy plus y square by dy. Now what I am going to do is bring this first term to left hand side. What happens? And e power x by y is also you take common outside. So this is a y dx minus x dy is equal to y square dy. Very nice. Y dx minus x dy. Y dx minus x dy. So that means what? You should have something in the denominator. Something if it is in the denominator, then you can apply the quotient rule. Take that y square to this side. So e power x by y into y dx minus x dy by y square is equal to 1 dy. Understand this? Understand? So this is equal to e power x by y. Yesterday class I have given a short formula for this. So this is nothing but derivative of x by y, 1 dy. Is it not the derivative of x by? Reverse order I told you to remember. If derivative of x by y is there, anybody can dig this. If this form is there, how to write down dxy. So everything is clear. So almost it is in the form of a variable and separable method. So write down integrating. Now what is the, see here, what is integral of e power x dx? This is e power x plus c. What is integral of y e power y? This is e power y plus c. E power x with respect to x, e power y with respect to y, that is equal to e power y you are getting. So here also e power x by y with respect to x by y you are getting. With respect to x by y you have to integrate. That's why your answer is e power x by y. This is y plus c. So this is your final answer. It is your final answer. Okay now. So this is called proper grouping the terms. You should develop this type of techniques. So if you start doing this problem like this, dy by dx is equal to y into e power x by y by x into e power x by y plus y square. If you start doing that, put some x by y is equal to some t, v or something, if you start doing, you will get almost very difficult to get the answer. So you should develop this type of techniques. This is called grouping the terms. So that is very important to solve the differential equation. Okay. I hope that you enjoyed today's class with some more problems and some more concepts. I will stand before you in the tomorrow's class. Until then, all the best.